Hello and welcome to Exercise 13 of Chapter 4, Training Course Manager, Part 5. Most of the explanations have already been made and each component trainer's courses schedule are very similar to those discussed in detail for participants. So, I am going to go through this quickly and only point out significant differences. I will start with trainers and follow the same data flow, starting with UI. Introduction to trainers.json. Note that the trainer data consists of objects for each trainer with an ID, a PID field, participant ID, and an expertise field. So, this relates into the participant on this PID. The reason being that the requirement was that all trainers must be participants. So, for normalization, the trainer's name and department are in participants.json, not duplicated in trainers.json. And external trainers are added to participants with a department external. Okay, with that introduction, now the code. Open trainersignal.svelte.js. In function update trainer, we are saving the updated signal set trainers, sorted by name, and because the name is in get participants, we have to do a little juggling here to achieve that. As you can see at the end of the code, we have the departments hard-coded. Obviously not a good idea, but for simplicity. And that's all I have to say about trainer signals. It's pretty much the same as participant signals and courses and schedules too. Open trainerview.svelte, chapter for trainer. Note that besides the expected trainer signals, we also import the get participant signal because of that relationship. I am breezing through this as there is nothing fundamentally different here than in participant view.svelte. Same logic, different dataset, fields. In markup note for the name and department, we have to get these from participants. The edit icon calls the update trainer local function, which updates the trainer signal and sets mode to update. That will then trigger the display of the editor component. Delete is handled here but still calling the signals file, again same thing as participant. And that's all there is to see here. Open trainereditor.svelte. Note that we are importing the departments from trainer signals. I added them here for simplicity instead of creating another set of data. The save trainer function calls the update trainer function in signals file, which will call the common API service update function, which will send the request, handled by +server.js, this time in the root API trainer folder and its associated data manager. Same as participants, just for trainers and trainers root. In the markup, if we add a trainer, we want to limit the selection to only those participants who are not already trainers, and we display the participants department. If not add i.e. update, then we just want to display the existing trainer's name and department and not allow these to be updated here, as that info is in participant. And that's trainer editor. And following the data flow, we can skip the API service as that's generic and common to all datasets, and we have covered that. We can also skip the +server.js, roots API, trainers, as other than the names of dataset, these are the same for all datasets. That brings us to trainer-data-manager.js in same folder as +server.js file for this dataset. And again, other than the path's file name and dataset names, nothing much different here. So, I will leave you to breeze through that. The next dataset is course.json. The object here has more information and in particular now tracks the trainer ID associated with the course. When you schedule a course, you can change the trainer for the course. It doesn't have to be the one associated with the course. But if you generally had a particular trainer handle a particular course, this is what the intention here is. Next, course-signals.svelte.js. Nothing significantly different here. Next, open course-view.svelte. OK, in the markup, look at the on-click and on-key down for delete. This calls a function handle delete, which calls the toggle delete signal function. So why not just call the signal file directly and remove the function as we did in trainers? We could. I didn't, as I wanted to show you the pros and cons. If you have a simple one-liner as in this case, you could just amend the event listeners. No question. Sometimes one-liners can be difficult to read, and a simple function call is much clearer. And you place your complex logic in the function. It can also be simpler to maintain, update. If you wanted to do other things than simply running another one-liner function, then having a handle delete function as in this case is a good idea. Next, course editor.svelte. Nothing significantly different here. And as we already said for courses, API handler, data manager have no significant differences from participants nor other datasets, so we don't need to review these. Last dataset, schedules.json. This file is the most complex as it has links to courses and trainers, and it also has an array for participants, for all the participants selected for a scheduled course. As you might imagine, we have some differences here. First, open scheduleview.svelte. Nothing significant in the script. In the markup, similar to other view components, it displays all schedules, however now it is looping through schedules and display the related course.name and the related trainer.name. Next, open scheduleeditor.svelte. Note that here we have a filtered participants array declared as we will display a list of possible participants and a selection can be made from these. The IDs for those selected will be saved to the participants field in the JSON file. Function toggle participants will toggle the selection of a participant. Function set trainer form course sets the trainer from the course that's selected as the default trainer, but you can choose any trainer. To end of the script we have an interesting effect. When selecting participants for a course we want to remove the trainer as the trainer can't be a participant, right, but also, we will not be giving any course for external trainers, denoted by participant.department equals of external. So, this effect filters those out. But we also want to make sure that previously selected participants, as saved in JSON in participants array with participant ID, are checked in the participant list. So that's what the map is doing. This loops over participants and keeps all existing data, participant, and adds a selected property, checks if participant.is is in new schedule.participants array, and marks participants as selected if they are part of the scheduled participants. So the .includes means it was in the new schedule.participants, which comes from JSON field, and if so, it gets a check and otherwise it does not. Now the is a bit overkill here because the new schedule.participants always exists, even if it's an empty array, but just in case for some rare reason it might not, the avoids a crash. The is the nullish coalescing operation. The what? It returns the right-hand value only if the left-hand value is null or undefined. So, if new schedule.participants didn't exist, would return false. This avoids an error if new schedule.participants is undefined or null. The markup follows the same structure as the other components. It differs in that it has an option to display a select participants. Nothing else to report here. And as mentioned after courses review, there are no significant differences with signals, API handler, and data manager. So, I will leave you to review those. And that completes the review of the Training Course Manager mini-app, exercise 13 of chapter 4. I hope you learnt a few things from that exercise, in particular the setup, organization, reasons for the structure and flow. Having JSON files actually made this more complex than if we had a DB, as we needed several routes and some duplication because of that. This also raised the issue of risk of duplication of IDs and overwriting data, which could happen relying on signals. Nevertheless, it's all useful knowledge. Before I wrap this up, here are the key concepts covered in this exercise. 1. Centralized state management use signals to manage and share state across components. 2. Reactive data flows from UI signals API server data manager and response flows back to UI. 3. Separation of concerns divided logic into signals, API handlers, and data managers. 4. Server-side data handling move data processing and persistence to the backend. 5. Dynamic data relationships managed linked entities like schedules, trainers, and participants. 6. API-driven state updates ensured UI stays updated with the latest server data. And that, my friends, is a wrap on exercise 13 of chapter 4, and I believe that's a wrap for chapter 4 exercises. I hope you enjoyed that. If you found any of the videos interesting, please drop a comment, like and subscribe. Thank you for watching. I have several challenges for chapter 4 stuff and will add a couple of mini-apps. See you there.